Welcome to This Explainer. Today, we're diving straight into the, frankly, mind-bending physics of our spinning planet. We're going to ask what actually happens when things go extremely wrong with Earth's rotation. From sudden violent stops to relativistic speeds, we'll explore the catastrophic extremes, and then we're going to bring it all the way back down to the very real, very tiny fluctuations that are literally messing with our digital clocks right now. Okay, so let's jump into this ultimate hypothetical question by looking at the visceral, apocalyptic reality of a sudden halt. It's a scenario that scientists have actually taken the time to model, and honestly, it paints a rather terrifying picture of physics in action. Astrophysicist Neil deGrasse Tyson actually hit the nail on the head with this one. Because of Newton's law of inertia, if the Earth suddenly hits the brakes, everything that isn't firmly bolted down simply keeps moving at the planet's previous speed. So you wouldn't just fall over, right? You would be violently launched. To put that into perspective, a sudden stop creates over 1,000 mile-per-hour eastern winds and massive instantaneous tsunamis right at the equator. That is 25 times the force of the strongest hurricane we've ever recorded. If you're standing in New York City, you're suddenly flying sideways at nearly 800 miles per hour. But check out the poles. Sitting at exactly 0 miles per hour of tangential velocity, they would remain strangely, almost perfectly undisturbed. But what if we tweak this into a totally different scenario? What if the Earth slows down gradually, say, over billions of years? In that case, we completely avoid being splattered by inertia, which is great, but the physical map of our world gets radically redrawn by the changing gravitational forces. See, without the centripetal force of our spin pushing outward, the Earth basically becomes a perfect sphere. That 8-kilometer bulge of ocean water that sits at the equator, it simply collapses. The oceans would migrate entirely to the poles, which exposes this massive, continuous equatorial megacontinent. Our days would stretch to 6 months of blistering, relentless sun, followed by 6 months of deadly winter. And worse, the liquid iron core in the center of the Earth stops swirling, which strips away the magnetic field that protects our planet from deadly space radiation. So yeah, not great either. All right, moving on to the 1-second day, speeding things up. Completely flipping the script here, what if we sped the Earth up so much that a day lasted just 1 single second? At that insane spin rate, the equator is moving at a staggering 10% the speed of light. At this velocity, centrifugal force completely overcomes gravity. It literally turns the Earth's crust into an expanding, relativistic buzzsaw. It would instantly vaporize our atmosphere, slice right through our satellite belts, and eventually turn the moon itself into a comet as all this planetary debris just sprays across the entire solar system. Which brings us to reality check, the delicate dance of time. Bringing this all back to reality, you really don't need to worry about expanding buzzsaws or sudden stops anytime soon. But our planet's rotation actually is constantly fluctuating due to things like tidal friction, earthquakes, and melting ice caps. To keep our incredibly precise atomic clocks perfectly aligned with this slightly unpredictable, wobbly spin, scientists have actually had to manually add 27 leap seconds since 1972. But here's the crazy part. Recently, the Earth has actually been spinning slightly faster. This means by 2029, we might need our first ever negative leap second. This manual tweaking causes so many software crashes globally that there's now a formal proposal to just abandon the leap second entirely by 2035. And all of that leads us to a pretty profound question. As climate change and tidal forces continue to subtly alter our spin, we're really left to wonder, how long can our rigid atomic timekeeping remain tethered to the natural rhythm of our rotating world? Are we actually ready to let human time and solar time just go their separate ways? Definitely something to think about the next time you check your watch. Thanks for joining me on this explainer, and keep asking the big questions.